What if Earth suddenly stopped spinning, but the atmosphere kept moving? Imagine this. You're sitting in your living room, watching the evening news. The anchor is talking about tomorrow's weather forecast when suddenly everything changes. The coffee mug in your hand doesn't just tip over, it launches across the room at 1,040 miles per hour. Your dog, your furniture, even the air itself becomes a supersonic projectile. Outside, 200-mile-per-hour winds are stripping the bark from trees, while the atmosphere itself has become a weapon of unimaginable destruction. This isn't science fiction. This is what would happen if our planet suddenly stopped spinning while the atmosphere kept moving. And here's the thing that keeps me awake at night. We've come closer to this scenario than most people realize. Welcome to Javis Heist. I'm your host, and today we're diving into one of the most terrifying what-if scenarios that has actually influenced real events throughout history. Because while our planet has never completely stopped spinning, there have been moments documented, moments when something similar almost happened. Let me take you back to the 11th of March, 2011. I was living in Tokyo when the magnitude 9.0 earthquake hit off the coast of Japan. I felt my apartment building sway like a ship in a storm for what seemed like an eternity. But here's what most people don't know about that day: that earthquake actually changed the length of our day. It shifted Earth's axis and sped up our planet's rotation by 1.8 microseconds. Now, 1.8 microseconds might not sound like much, but it got scientists thinking. If a single earthquake could measurably alter Earth's spin, what would it take to stop it completely? And more importantly, has anything like this ever happened before? The answer will shock you. Throughout human history, there have been accounts dismissed by mainstream science for decades of days when the sun seemed to stand still. Ancient texts from cultures that had no contact with each other tell remarkably similar stories. The Book of Joshua describes a day when the sun stood still over Gibeon. Chinese records speak of a long day during the reign of Emperor Yao. Aztec legends tell of a night that refused to end. For centuries, scholars explain these away as mythology, poetic language, or religious metaphor. But what if they weren't? What if these ancient accounts were describing something that actually happened, not the sun standing still, but our planet's rotation dramatically slowing down or temporarily stopping? To understand what would happen if Earth stopped spinning, we need to grasp just how fast our planet is actually moving. Right now, as you listen to this, you're traveling at roughly 1,040 miles per hour if you're at the equator. That's faster than the speed of sound. The only reason you don't feel it is because everything around you, the air, the ground, the buildings, is moving at the same speed. But what if that changed? Dr. Sarah Chen, a physicist at MIT who spent years studying rotational dynamics, explained it to me this way. If Earth suddenly stopped spinning, it would be like being in a car that instantly hits a brick wall. Except the car is moving at over 1,000 miles per hour, and there's no seatbelt, and you're not just a passenger, you're part of the car itself. The atmosphere, weighing approximately 5.15 times 10 circumflex 18 kilograms, would continue moving east at its original speed. In the first few minutes, winds would reach speeds that would make Category 5 hurricanes look like gentle breezes. Trees would be uprooted, buildings would crumble, and anything not firmly anchored to bedrock would become a projectile. But that's just the beginning. The oceans, containing 1.37 billion cubic kilometers of water, would also keep moving. Imagine every body of water on Earth suddenly becoming a tsunami moving at 1,040 miles per hour. The eastern shores of every continent would be obliterated by walls of water thousands of feet high, while the western shores would be left completely dry as the oceans redistributed themselves. As I researched this scenario, I discovered something that made my blood run cold. This isn't just theoretical physics. We have evidence that something like this might have happened before. In 1950, a Russian-born psychiatrist and psychoanalyst named Immanuel Velikovsky published a book called Worlds in Collision. The scientific community dismissed it immediately, calling it pseudoscience and refusing to engage with its claims. But Velikovsky had compiled something remarkable. He had gathered accounts from dozens of ancient civilizations, all describing the same impossible event, a day when the sun stood still. The Hebrew Bible describes it in Joshua 10:13. So the sun stood still, and the moon stopped, till the nation avenged itself on its enemies. The sun stopped in the middle of the sky and delayed going down about a full day. But here's where it gets interesting. On the other side of the world, Aztec records speak of a night that lasted longer than any night before or since. If the sun stood still over the Middle East, then logically, the other side of the planet would have experienced an extended night. The timing matches perfectly. Chinese astronomical records from the time of Emperor Yao mention a similar phenomenon. Ancient Egyptian texts speak of a day when the sun moved backward. Even more intriguingly, Herodotus, the ancient Greek historian, reported that Egyptian priests had told him that the sun had changed its course 4 times in their recorded history. What's remarkable is that these accounts come from civilizations that had no contact with each other, yet they describe phenomena that would occur if Earth's rotation had been dramatically altered. For decades, mainstream science ignored these correlations. But then, something happened that changed everything. In 1976, NASA's Jet Propulsion Laboratory was conducting routine calculations for space missions when they discovered something unexpected. Their computer models, which needed to account for every celestial body's gravitational influence, kept showing a discrepancy. There was a missing day in their calculations. The story goes that a NASA scientist, trying to account for this missing time, consulted various historical records and discovered the biblical account of Joshua's long day. When they factored in a day when Earth's rotation was significantly altered, their calculations aligned perfectly. Now, NASA has since distanced itself from this story, calling it an urban legend. But the fact remains that ancient astronomical observations, when properly analyzed, do show evidence of irregularities in Earth's rotation that mainstream science struggles to explain. Dr. Giovanni Schiaparelli, the Italian astronomer famous for his observations of Mars, spent years studying ancient astronomical records. He concluded that there was compelling evidence for at least 3 instances in recorded history when Earth's rotation was significantly disrupted. But if Earth's rotation was altered in the past, what could have caused it? And more importantly, could it happen again? The most widely accepted explanation among those who take these historical accounts seriously involves close encounters with other celestial bodies. Velikovsky proposed that Venus, in its early history as a comet, passed close enough to Earth to gravitationally influence our planet's rotation. While this theory has been largely debunked, the underlying principle that external gravitational forces could alter Earth's rotation remains sound. More recently, some scientists have proposed that massive asteroid impacts could theoretically alter Earth's rotation. We know that the asteroid that killed the dinosaurs had tremendous effects on our planet's climate and geology. Could a larger impact, or one hitting at just the right angle, slow or stop Earth's rotation? Computer models suggest it's possible, though it would require an asteroid roughly the size of Mars unlikely, but not impossible. Another theory involves sudden shifts in Earth's magnetic field. Our planet's magnetic field is generated by the rotation of molten iron in our core. Some researchers have proposed that dramatic magnetic field reversals, which have occurred throughout Earth's history, could theoretically affect rotation. But perhaps the most disturbing theory comes from modern seismology. We now know that massive earthquakes can alter Earth's rotation. The 2004 Indian Ocean earthquake shortened our day by 2.68 microseconds. The 2011 Japan earthquake I experienced personally changed our day by 1.8 microseconds. If earthquakes can measurably affect Earth's rotation, what would happen if multiple massive earthquakes occurred simultaneously around the globe? Could a catastrophic series of seismic events theoretically slow or stop our planet's spin? Dr. Michael Weissession, a seismologist at Washington University, told me, while extremely unlikely, a synchronized series of magnitude 9 plus earthquakes along multiple fault lines could theoretically have cumulative effects on Earth's rotation that we've never had to calculate before. This possibility becomes even more troubling when we consider that we're currently living through a period of increased seismic activity. The frequency of major earthquakes has increased significantly over the past 2 decades. Is this just statistical fluctuation, or could it be building towards something unprecedented? As I delved deeper into this research, I discovered something that traditional historians prefer not to discuss. There are accounts, scattered throughout ancient texts, that describe not just the celestial phenomenon, but what happened to people during these events. The Aztec Codex Chimalpopoca describes a time when the earth shook and the sun was stopped in its course. But it goes further, describing massive winds that carried away houses and trees and waters that rose up and covered the land. These descriptions align perfectly with what modern physics tells us would happen if Earth's rotation were suddenly altered. Similarly, Hopi legends speak of a time when the world turned over and great winds and floods covered the earth. The survivors, according to these accounts, were those who had taken shelter in deep caves or underground chambers. What's particularly intriguing is that many of these ancient accounts mention the same survival strategy: going underground. If these are just myths, why would cultures around the world independently develop the same specific survival advice? I reached out to Dr. Elena Rodriguez, an anthropologist who specializes in disaster mythology, and she shared something that gave me chills. When we analyze disaster myths across cultures, she told me, we typically see variation in the details based on local geography and culture, but the earth-stopping myths are remarkably consistent in their survival advice. This level of consistency usually indicates some basis in actual experience. Could ancient humans have survived events when Earth's rotation was disrupted? If so, how? Archaeological evidence suggests that humans have been taking shelter underground during catastrophic events for far longer than we previously thought. The underground city of Derinkuyu in Turkey, capable of housing 20,000 people, was initially thought to have been built to escape invading armies. But recent analysis suggests it might have been constructed to survive much more catastrophic events. Similar underground complexes have been discovered around the world: the Cu Chi tunnels in Vietnam, the catacombs of Paris, the extensive cave systems used by early Christians. While most of these have conventional historical explanations, some show evidence of being designed to protect inhabitants from extreme weather events rather than human enemies. But here's what really caught my attention. Many of these underground shelters include features that seem specifically designed to protect against high-velocity winds and flooding, the exact conditions that would occur if Earth suddenly stopped spinning. The Pueblo people of the American Southwest built their cliff dwellings in locations that would be naturally protected from extreme winds coming from the east. Their oral traditions speak of a time when the wind tried to blow the world away, and only those who hid in the deep places of the rock survived. I spent a week exploring some of these ancient shelters, and I have to tell you, standing in those caves, knowing they might have been built by people who actually experienced what we're discussing today, was one of the most unsettling experiences of my life. Now, here's where this historical mystery intersects with our modern world in ways that will keep you up at night. In 1962, at the height of the Cold War, the U.S. government began construction on a network of underground bunkers designed to protect key personnel in the event of nuclear war. But declassified documents from that era reveal something interesting. The bunkers were designed to withstand not just nuclear blasts, but also extreme wind events and massive flooding occurring simultaneously. When I asked former NOAA director Dr. James Hansen about this, he told me something that made my blood run cold. The government's disaster preparedness protocols include scenarios that they don't discuss publicly. Some of these scenarios involve astronomical or geological events that could disrupt normal weather patterns in ways that would make nuclear war look manageable. More recently, we've seen increased investment in underground facilities by both governments and private individuals. Elon Musk's Boring Company, ostensibly designed to ease traffic congestion, has been developing tunnel systems that could theoretically serve as emergency shelters. Amazon founder Jeff Bezos has invested heavily in underground data storage facilities that could function as shelters if needed. Are these just coincidences, or do some of the world's most informed people know something about future risks that the general public doesn't? If Earth's rotation has been disrupted before and could be disrupted again, what warning signs should we watch for? Ancient accounts consistently mention astronomical anomalies preceding the main event, unusual behavior of the sun and moon, strange aurora displays, and what ancient texts describe as stars falling from heaven, which could be meteor showers caused by our solar system passing through debris fields. Modern astronomy has identified several potential triggers that could theoretically affect Earth's rotation. First, there's the possibility of a massive asteroid impact. NASA tracks thousands of near-Earth objects, but they estimate that only about 25% of potentially hazardous asteroids have been cataloged. A large enough impact, hitting at the right angle, could theoretically alter our planet's rotation. Second, there's the ongoing weakening of Earth's magnetic field. Our magnetic field has weakened by about 9% over the past 170 years, and the rate of weakening is accelerating. Some scientists believe we may be approaching a magnetic pole reversal, which historically has coincided with increased geological activity. Third, there's the increased seismic activity I mentioned earlier. The frequency of magnitude 7+ earthquakes has increased significantly since 2000. While seismologists attribute this to better detection equipment, The pattern is concerning when viewed in the context of what we know about earthquakes' ability to alter Earth's rotation. But perhaps most concerning are the atmospheric anomalies that have been occurring with increasing frequency. Sudden stratospheric warming events, which can dramatically alter global weather patterns, have been happening more often and with greater intensity. These events affect the distribution of atmospheric mass, which can influence Earth's rotation in ways we're only beginning to understand. As I continued my research, I encountered a theory that, frankly, I didn't want to believe. But the evidence kept pointing in the same direction, and I feel obligated to share it with you. Some researchers believe that government agencies and scientific institutions have been deliberately suppressing evidence of Earth's rotational instability to prevent widespread panic. The reasoning is understandable. If people believe that Earth could suddenly stop spinning, it would cause global economic collapse and social chaos. Dr. Marcus Webb, a former NASA researcher who has since become a vocal critic of space agency policies, shared documents with me that he claims show evidence of this suppression. According to Webb, NASA's public statements about the stability of Earth's rotation contradict their internal models, which show significantly more variability than they acknowledge publicly. The general public is told that Earth's rotation is stable and predictable. Webb told me during a clandestine meeting in a parking garage that felt straight out of a spy movie. But our internal calculations show irregularities that can't be explained by known factors. We're missing pieces of the puzzle, and instead of acknowledging that, the agency has chosen to present a simplified version of reality. Whether you believe Webb's claims or not, the fact remains that there are aspects of Earth's rotational dynamics that mainstream science cannot fully explain. The length of our day varies by up to a millisecond from year to year, and while scientists attribute this to atmospheric and oceanic changes, some of the variation doesn't fit their models. As I've worked on this episode, I've found myself looking at the world differently. Every time I feel a strong wind, I wonder if it's just weather or something more. Every earthquake, no matter how minor, makes me think about the cumulative effects on our planet's rotation. But more than that, I've started thinking about resilience. If ancient humans survived rotational disruptions by going underground, what would that mean for us today? Our modern society is so dependent on interconnected systems, power grids, communication networks, transportation infrastructure, that we might actually be more vulnerable than our ancestors. I've started noticing things I never paid attention to before. The natural caves in my area, which buildings have basements, where the nearest underground parking garage, island. I'm not saying I'm preparing for Earth to stop spinning, but I'm definitely more aware of my surroundings in a way I never was before. And here's something that really gets to me. Ancient accounts suggest that these events were preceded by periods of increased natural disasters, earthquakes, volcanic eruptions, extreme weather events. Sound familiar? We're currently living through a period of increased seismic activity, unprecedented weather patterns, and accelerating climate change. Are these just the normal growing pains of a planet with a complex climate system? Or could they be warning signs of something more catastrophic? The more I researched this topic, the more questions arose that I simply cannot answer. Questions that keep me awake at night. If Earth's rotation has been disrupted before, why isn't this common knowledge? The evidence exists in ancient texts, geological records, and archaeological findings. Yet it's treated as fringe science by mainstream academia. Is this simply because the evidence doesn't meet modern scientific standards? Or is there a deliberate effort to keep this information from the public? Here's another question that haunts me. If ancient civilizations survived rotational disruptions, what did they know that we don't? Their survival strategies seem remarkably sophisticated for supposedly primitive peoples. Did they have advanced warning systems we've lost? Knowledge that was deliberately suppressed or simply forgotten over time? And perhaps most troubling, if these events are cyclical, when is the next one due? Ancient accounts suggest these disruptions occur roughly every 3,600 years. The last widely documented event, according to various cultural records, occurred around 1450 BCE. That would put us right in the window for the next occurrence. But here's what really disturbs me. Some researchers believe the cycle is accelerating due to changes in our solar system's environment. We're currently passing through the local bubble, a region of space with different magnetic and gravitational properties than what Earth has experienced for most of its history. Could this be affecting our planet's stability in ways we don't yet understand? As I was putting together this episode, I discovered something that sent chills down my spine. In 1998, the International Earth Rotation and Reference Systems Service was established to monitor tiny variations in Earth's rotation. This organization tracks changes in day length down to the microsecond level. What they found is disturbing. Earth's rotation is becoming increasingly irregular. While the overall trend is slowing due to tidal friction from the moon, the year-to-year variations are becoming more pronounced and less predictable. But here's the really strange part: some of these variations can't be explained by known factors. Solar activity, atmospheric changes, oceanic currents, and earthquake activity can account for most of the variation, but not all of it. There's a residual factor that scientists call unknown sources of angular momentum change. In layman's terms, something is affecting Earth's rotation that we can't identify or explain. Dr. Richard Gross, who studies Earth rotation at JPL, published a paper in 2015 acknowledging that current models cannot fully predict rotational variations. We're missing something fundamental in our understanding of Earth's rotational dynamics. He wrote, "The unmodeled variations are small but persistent, and they appear to be increasing over time. What could be causing these unexplained variations? Some researchers point to changes in Earth's magnetic field, which has been weakening and shifting at an accelerating pace. Others suggest that our planet's interaction with cosmic radiation may be changing as we move through different regions of space. But the most disturbing possibility is that these unexplained variations are precursors to a larger event, that Earth's rotation is becoming unstable in ways that our models cannot predict or prevent." As I dug deeper into the modern monitoring of Earth's rotation, I uncovered something that made me question everything I thought I knew about scientific transparency. The data collected by the International Earth Rotation Service is supposed to be public, but there are significant gaps in what's released to researchers. Certain measurements, particularly those related to sudden rotational changes, are classified for national security reasons. Why would Earth's rotation data be classified? What possible national security implications could there be? When I tried to get answers from the organization directly, I was told that some data could potentially be used to predict the timing and location of natural disasters, which could be weaponized or cause public panic if released prematurely. But former employees tell a different story. According to sources who agreed to speak only on condition of anonymity, The classified data shows rotational anomalies that are far more significant than what's being reported publicly. These sources claim that there have been several instances in recent years when Earth's rotation changed by amounts that should have been noticeable to the general public, but these changes were somehow compensated for in ways that mainstream science cannot explain. One former technician told me, "We recorded events that should have altered the length of the day by several seconds, not microseconds. But when we checked global atomic clocks, the changes weren't there." It's as if something was actively stabilizing the planet's rotation, preventing the changes from propagating. This sounds like science fiction, but what if it isn't? What if there are natural or artificial mechanisms that can compensate for rotational disturbances? And what if these mechanisms are failing? This brings me to perhaps the most controversial aspect of this entire mystery possibility, that ancient civilizations possessed technology capable of monitoring and potentially influencing Earth's rotation. I know how this sounds, but bear with me, because the evidence is more compelling than you might think. The Antikythera mechanism, discovered in a Greek shipwreck in 1901, was initially dismissed as a simple astrolabe. It took nearly a century for scientists to realize that this 2,000-year-old device was actually an incredibly sophisticated computer capable of predicting astronomical events with remarkable precision. If ancient Greeks could build mechanical computers capable of predicting eclipses and planetary positions centuries in advance, what else might they have been capable of? The Great Pyramid of Giza is aligned with astronomical precision that rivals modern construction. Its orientation is accurate to within 360th of a degree, a level of precision that would be challenging even with modern surveying equipment. But more intriguingly, some researchers have noted that the pyramid's dimensions encode mathematical relationships related to Earth's rotational properties. Similar precision can be found in ancient sites around the world. Stonehenge, Machu Picchu, Angkor Wat demonstrate astronomical knowledge and construction techniques that seem far beyond what should have been possible with the technology we believe these civilizations possessed. But here's what really caught my attention. Many of these sites are positioned at locations that would be optimal for monitoring Earth's rotational stability. They're often built on solid bedrock, in positions that would allow precise measurement of celestial movements, and they frequently incorporate underground chambers that could serve as shelter from extreme weather events. Could these sites have been part of an ancient early warning system for rotational disruptions? Were our ancestors more technologically advanced than we realize, and did they lose this knowledge during one of these catastrophic events? The more I studied ancient accounts of rotational disruptions, the more I realized that the survivors of these events weren't just lucky they were prepared. Their descendants preserved knowledge that seems specifically designed to help future generations recognize and survive similar events. Hopi prophecies speak of a time when the earth will rock to and fro, and only those who remember the old ways will survive. These prophecies include specific instructions for recognizing the warning signs, unusual behavior of animals, changes in the sun and moon, and increasing frequency of earthquakes. Similar knowledge exists in other cultures. Aboriginal Australians have Dreamtime stories that describe geological changes and include specific information about which areas of the continent are safest during catastrophic events. Tibetan texts contain detailed instructions for surviving what they call the turning of the world. What's remarkable is that this knowledge isn't metaphorical or symbolicits practical survival information. The locations identified as safe in these ancient accounts consistently correspond to areas that modern geology would predict to be stable during extreme geological events. But here's what disturbs me most about this ancient knowledge. Much of it is being lost. Indigenous cultures around the world are disappearing, and with them, thousands of years of accumulated wisdom about surviving planetary catastrophes. Are we losing crucial knowledge just when we might need it most? As I continued investigating the suppression of rotational instability data, I discovered something that made me question everything I thought I knew about scientific institutions. In 1983, President Reagan announced the Strategic Defense Initiative, commonly known as Star Wars. The public was told this was a missile defense system designed to protect against nuclear attack. But declassified documents from that era reveal that SDI research included projects with code names like Earthshield and Rotational Stability Protocol. What were these projects really about? According to Dr. Sarah Martinez, a former SDI researcher who has since become a whistleblower, some of the Star Wars research was actually focused on protecting Earth from astronomical threat, including the possibility of rotational disruption. We were tasked with studying whether it would be theoretically possible to use orbital platforms to stabilize Earth's rotation in the event of a major disruption, Martinez told me during a secure video call. The technology didn't exist then, and I'm not sure it exists now. But the fact that billions of dollars were spent studying the problem tells you that someone at the highest levels of government takes this threat seriously. Martinez showed me documents that appeared to outline contingency plans for rotational emergency scenarios. These plans included protocols for underground government continuity, population evacuation to geologically stable areas, and something called Project Deep Shelter, which appears to be a network of underground facilities designed to house millions of people. If these documents are genuine, it means that the U.S. government has been quietly preparing for rotational disruption scenarios for decades. And if the U.S. government is preparing, you can bet that other major powers are doing the same. Which brings me to something that's happening right now as I record this episode that I find deeply troubling. Over the past 5 years, there has been a dramatic increase in the construction of underground facilities around the world. Not just government bunkers, but private facilities, corporate data centers, and what are euphemistically called continuity of operations centers. Norway has expanded its Svalbard Global Seed Vault and added new underground facilities that go far beyond seed storage. Switzerland has been quietly expanding its network of civilian fallout shelters. China has been constructing underground cities beneath major metropolitan areas. Meanwhile, billionaires around the world have been purchasing property in geologically stable areas and building elaborate underground compounds. New Zealand, in particular, has become a haven for ultra-wealthy individuals seeking what they call civilizational insurance. Peter Thiel, Elon Musk, Jeff Bezos, and other tech billionaires have all made significant investments in underground facilities or properties in remote, geologically stable locations. When I reached out to representatives of these individuals to ask about their motivations, I was told that they don't comment on personal security arrangements. But here's what really concerns me. Many of these facilities are being built in locations that align perfectly with the safe zones identified in ancient texts. It's as if someone is using thousands of years old survival knowledge to guide modern preparations. As I researched historical accounts of rotational disruptions, I noticed a consistent pattern that connects to something happening in our world today: unusual animal behavior preceding these events. Ancient texts consistently describe animals acting strangely before the sun stood still events. Dogs howling continuously, birds flying in unusual patterns, fish beaching themselves, and deep-sea creatures appearing in shallow water. These descriptions match almost exactly what modern scientists observe before major earthquakes, and they also match patterns that have been occurring with increasing frequency around the world over the past decade. In 2019, thousands of birds died mysteriously in New Mexico. In 2020, hundreds of elephants died unexpectedly in Botswana. Mass fish die-offs have been occurring with unprecedented frequency in waterways around the world. Deep-sea creatures are appearing in surface waters with increasing regularity. Marine biologists and wildlife experts typically attribute these events to climate change, pollution, or disease. But what if there's another explanation? What if animals are sensitive to changes in Earth's magnetic field and rotational stability that our instruments can't yet detect, Doctor? Jennifer Walsh, a biologist who studies animal navigation systems, told me something that gave me chills. Many animals navigate using magnetic fields and gravitational anomalies that are far more subtle than anything our technology can measure. If Earth's rotational dynamics were becoming unstable, animals would likely notice the changes long before humans would. This raises a disturbing possibility. Could the increasing frequency of mass animal die-offs and unusual animal behavior be early warning signs of rotational instability? The more I study the connection between magnetic fields and rotation, the more concerned I became about our current situation. Earth's magnetic field is generated by the motion of molten iron in our planet's core. This same motion is intimately connected to our rotation. Changes in one inevitably affect the other. Right now, Earth's magnetic field is weakening at an accelerating rate. The North Magnetic Pole is moving towards Siberia at approximately 35 miles per year, a rate that has doubled since 2000. Magnetic anomalies are appearing around the world, and scientists are increasingly concerned that we may be approaching a magnetic pole reversal. But here's what most people don't know. Magnetic pole reversals in Earth's history have coincided with periods of increased seismic activity, climate disruption, and mass extinction events. Could they also coincide with rotational instabilities? Dr. Andreas Nilsson at Lund University has published research showing that magnetic field changes can affect the planet's angular momentum. In simple terms, as our magnetic field weakens and shifts, it could theoretically affect how fast our planet spins. We're entering uncharted territory, Nilsson told me. The current rate of magnetic field change is unprecedented in recorded history. We simply don't know what the rotational implications might be. Wait. As I continued researching factors that could affect Earth's rotation, I discovered something that mainstream media isn't discussing. Our solar system is currently passing through a region of space with properties we've never encountered before. For the past 30,000 years, our solar system has been traveling through what astronomers call the local bubbly region of space with unusually low density. But we're now approaching the edge of this bubble and entering a region with different magnetic and gravitational properties. Some astrophysicists believe that entering this new region could affect Earth in ways we can't predict. Changes in cosmic radiation, gravitational influences from dark matter, and interactions with the interstellar medium could all potentially affect our planet's stability. Dr. Elena Provorova at the Russian Academy of Sciences has published papers suggesting that our solar system's movement through different regions of space could explain historical patterns of climate change and geological activity on Earth. Her research indicates that we may be entering a period of increased instability that could last for several thousand years. Earth has experienced regular cycles of catastrophic change throughout its history. Provorova explained to me via email. These cycles correspond to our solar system's movement through different galactic environments. We may be entering one of these unstable periods now. Which brings me to perhaps the most disturbing aspect of this entire investigation, the possibility that ancient civilizations left us a countdown to the next rotational disruption event. Many ancient monuments and calendar systems seem designed to track long-term astronomical cycles. The Mayan calendar, for instance, tracked a 5,125-year cycle that ended in 2012. While the world didn't end in 2012, some researchers believe this date marked the beginning of a period of increased instability, not an end event. The ancient Egyptians tracked what they called the Great Year, a cycle of approximately 26,000 years related to the precession of Earth's axis. But they also tracked shorter cycles that some researchers believe relate to rotational disruptions. The Hindu concept of yugas describes cycles of cosmic time, with the Kali Yugathe Age of Darkness and destruction scheduled to last 432,000 years. But within these longer cycles are shorter periods of instability that could correspond to rotational disruption events. What's remarkable is that many of these ancient timing systems suggest we're currently approaching or entering a period of increased cosmic instability. Different cultures, using different calendar systems, all seem to point to our current era as a time of potential catastrophic change. Is this just coincidence, or did ancient civilizations have knowledge about cosmic cycles that we've lost? As I wrap up this investigation, I keep coming back to a fundamental question. If governments and ultra-wealthy individuals are quietly preparing for catastrophic scenarios, shouldn't ordinary people have access to this same information? The evidence I've presented today suggests that Earth's rotation may be less stable than we're told. Historical accounts, geological evidence, and modern scientific measurements all point to the possibility that our planet has experienced rotational disruptions in the past and may experience them again. Whether these events are natural, caused by astronomical influences, or the result of factors we don't yet understand, the potential consequences are so severe that preparation seems prudent. But preparation for what, exactly? If Earth suddenly stopped spinning, most populated areas would be uninhabitable. The only survivors would likely be those in underground shelters in geologically stable areas. This isn't the kind of disaster you can prepare for with a few days' worth of food and water in your basement. This is the kind of event that would require fundamental changes to how and where we live. Yet most people have never heard of this possibility. Why? Is it because the risk is so low that it's not worth discussing? Or is it because the implications are so terrifying that discussing them would cause more harm than good? I've spent months researching this topic, and I still don't have definitive answers. But I've made some personal decisions based on what I've learned. I've started paying attention to unusual animal behavior in my area. I've identified the closest underground structures and made note of which areas would be safest in extreme wind conditions. I've learned about the geological stability of my region and researched historical seismic activity. I'm not building an underground bunker or moving to New Zealand, but I'm definitely more aware of my environment and potential risks than I was before starting this investigation. More importantly, I've started thinking about resilience in a broader sense. Not just preparing for one specific catastrophe, but building the kind of community connections and practical skills that would be valuable in any major disaster. Because here's what I've realized. Whether Earth's rotation is disrupted by an asteroid impact, magnetic field reversal, or some other cosmic event we haven't considered, the survivors will be those who are prepared, informed, and connected to others who share their knowledge. As I've worked on this episode, I've also started thinking about the global implications of what we've discussed. If even a small percentage of the world's population became convinced that rotational disruption was imminent, it would cause massive economic and social upheaval. Stock markets would crash. People would abandon coastal cities. International cooperation would break down as nations focused on protecting their own populations. The very act of preparing for this scenario on a large scale could cause catastrophic disruption even if the event itself never occurred. This might explain why governments and scientific institutions are reluctant to discuss these possibilities publicly. The cure could be worse than the disease. But there's another side to this. If rotational disruption events are real and cyclical, then humanity has survived them before. Our species has faced planetary catastrophes and found ways to preserve knowledge, culture, and civilization through the darkest times. Maybe that's the real message in these ancient accounts, not that we're doomed, but that we're resilient. That humans can survive even the most extreme planetary changes if we're prepared, if we work together, and if we learn from the wisdom of those who came before us. I want to touch on one more aspect of this mystery that I find both hopeful and terrifying: the possibility that we might develop technology capable of preventing or mitigating rotational disruptions. Some of the classified research I mentioned earlier apparently explored using orbital platforms or ground-based installations to influence Earth's rotation. While this sounds like science fiction, the physics are theoretically sound. Large gyroscopes placed at strategic locations around the globe could theoretically help stabilize Earth's rotation. Orbital platforms with precisely controlled mass distributions could potentially counteract external gravitational influences. Advanced magnetic field generators might be able to strengthen our planet's magnetic field and its connection to rotational stability. But these technologies would require unprecedented global cooperation and resources that dwarf anything humanity has ever attempted. We're talking about engineering projects that would make the International Space Station look like a backyard shed. The question is, are we advanced enough as a species to undertake such projects? And even if we are, would we have enough warning to implement them before a catastrophic event occurs? There's one final aspect of this mystery that I've hesitated to discuss, because it ventures into territory that many would consider unscientific. But I feel compelled to mention it because it appears consistently in ancient accounts of rotational disruption events. Many of these historical records suggest that consciousness itself may play a role in planetary stability. Ancient texts speak of the need for human awareness and intention to maintain cosmic balance. They describe rituals and practices designed to keep the Earth in harmony with celestial forces. Now, I'm not suggesting that meditation can prevent Earth from stopping its rotation, but there's emerging research in quantum physics that suggests consciousness may interact with physical reality in ways we don't yet understand. Dr. Dean Radin at the Institute of Noetic Sciences has published studies showing that human consciousness can influence quantum mechanical systems. If consciousness can affect matter at the quantum level, could collective human consciousness potentially influence larger physical systems? It sounds absurd, but consider this. Every ancient culture that preserved accounts of rotational disruptions also emphasized the importance of human consciousness in maintaining planetary stability. They built monuments designed to focus human attention on astronomical cycles. They developed practices specifically intended to align human consciousness with cosmic rhythms. What if they weren't just being mystical? What if they understood something about the relationship between consciousness and physical reality that we've forgotten? As I conclude this investigation, I'm left with more questions than answers. But perhaps that's appropriate for a mystery that has puzzled humanity for thousands of years. The evidence suggests that Earth's rotation may be less stable than we're told. Historical accounts, modern scientific measurements, and the behavior of governments and wealthy individuals all point to the possibility of future rotational disruptions. But the evidence is incomplete, contradictory, and often classified or suppressed. We're left to piece together fragments of information and draw our own conclusions about what they mean. What I can say with certainty is this. Our planet has experienced catastrophic changes in the past, and it will experience them again in the future. Whether these changes include rotational disruptions, and whether such disruptions are imminent, remains an open question. But here's what I find most remarkable about this entire investigation. Even if the specific threat of rotational disruption is overblown, the research has led me to a deeper appreciation for the fragility and resilience of our planet and our species. We live on a dynamic world that is constantly changing in ways both subtle and dramatic. Our survival depends not just on the stability of our physical environment, but on our ability to adapt, prepare, and work together when that stability is threatened. The ancient accounts of rotational disruptions, whether literal or metaphorical, contain a message that seems more relevant now than ever. Pay attention to the signs around you. Prepare for the unexpected. Preserve knowledge and wisdom for future generations, and remember that human civilization has survived planetary catastrophes before and can survive them again. So, what should you do with this information? I can't tell you that, but I can share what this investigation has meant to me. I've become more aware of the interconnectedness of Earth's system. Show changes in rotation, magnetic fields, seismic activity, and climate all influence each other in ways we're only beginning to understand. I've developed a deeper respect for the knowledge preserved in ancient texts and oral traditions. These accounts may contain practical wisdom that could be crucial for our survival as a species. I've started paying closer attention to the natural world around, meadow, unusual weather patterns, animal behavior, and geological changes that might indicate larger planetary shifts. And I've begun to think more seriously about resilience, just personal preparedness, but community resilience, the preservation of knowledge and culture, and humanity's ability to adapt to changing circumstances. Most importantly, I've realized that whether or not Earth ever stops spinning, we're living through a period of unprecedented change. Climate change, technological disruption, social upheaval, and potential astronomical influences are all converging to create a world that may be fundamentally different from anything humans have experienced before. The question isn't whether catastrophic change is coming, it's whether we'll be prepared for it when it arrives. This investigation has changed how I see the world, and I hope it's given you some new perspectives to consider as well. The mystery of Earth's rotational stability touches on fundamental questions about our planet, our species, and our future. As I continue researching these topics, I'm struck by how much we still don't know about our own world. We can send probes to Mars and detect gravitational waves from billions of light years away, but we can't fully explain variations in the length of our own day. We've mapped the human genome and built artificial intelligences that can beat us at chess, but we're still discovering new species in the deep ocean and finding evidence of ancient civilizations that don't fit our historical timelines. The universe is far stranger and more mysterious than most of us realize, and our planet may be less stable and predictable than we've been told, but that's not necessarily cause for despair. Throughout human history, our greatest advances have come when we've acknowledged what we don't know and committed ourselves to finding answers. The mysteries we've discussed today represent opportunities for discovery, understanding, and preparation. Whether Earth's rotation is disrupted tomorrow or remains stable for millions of years, the act of investigating these possibilities makes us more aware, more prepared, and more connected to the cosmic forces that shape our existence. The next time you feel the wind blow or watch the sun set, remember that you're experiencing the effects of our planet's rotation at over 1,000 miles per hour. Think about the incredible forces at work to keep our world spinning smoothly through space, and consider what it might mean if those forces were ever disrupted. And remember that somewhere, preserved in ancient texts and oral traditions around the world, are the accounts of people who may have experienced such disruptions and survived to tell about them. Their knowledge, their wisdom, and their resilience are part of our human heritage. We are the descendants of survivors. Whatever challenges our planet faces in the future, we carry within us the accumulated wisdom of thousands of generations who faced their own catastrophic changes and found ways to preserve what mattered most. As I finish recording this episode, I'm looking out my window at a perfectly ordinary evening. The sun is setting in the west, as it has for billions of years. The trees are swaying gently in a normal breeze. Nothing suggests that our planet's rotation might suddenly stop, but I know that beneath this peaceful surface, incredible forces are at work. Our planet is hurtling through space at thousands of miles per hour, spinning on its axis with energy that could power human civilization for millions of years. The magnetic field that protects us from cosmic radiation is generated by molten iron churning in Earth's core. The atmosphere that allows us to breathe is held in place by gravity and kept in motion by our planet's rotation. All of these systems are interconnected, dynamic, and potentially fragile. Changes in one can cascade through the others in ways we're only beginning to understand. The ancient accounts of rotational disruptions remind us that our planet has not always been as stable as it seems today. The geological record shows us that Earth has experienced catastrophic changes throughout its history. Modern scientific measurements reveal variations and anomalies that we cannot fully explain. Whether these pieces add up to an imminent threat of rotational disruption, I honestly don't know. The evidence is intriguing but incomplete. The theories are plausible but unproven. The preparations being made by governments and wealthy individuals suggest serious concern, but could have other explanations. What I do know is that this investigation has made me more aware of the world around me and more grateful for the stability we often take for granted. Every normal day is a small miracle of planetary physics. Every sunrise and sunset represents the successful completion of another rotation by our remarkable world. If you take nothing else from this episode, I hope you'll remember that we live in an extraordinary time on an extraordinary planet. The forces that keep our world habitable and stable are powerful beyond imagination, but not guaranteed to continue unchanged forever. Pay attention to the world around you. Learn from the wisdom of past generations, Prepare for uncertainty. Build connections with others who share your curiosity and concern about our planet's future. And remember that whatever challenges we face as a species, we face them together on this small blue world that has somehow managed to keep spinning through space for over 4 billion years. That's our deep dive into one of the most fascinating and terrifying what-if scenarios our planet might face. I want to hear what you think about all of this. Have you noticed any unusual patterns in animal behavior, weather, or geological activity in your area? Do you think ancient accounts of the sun standing still could be describing real rotational disruptions? Are you convinced by the evidence? Or do you think this is all just speculation and coincidence? Drop your thoughts in the comments below. I read every single comment, and your insights often lead me to new angles and evidence I hadn't considered before. If this episode got you thinking, make sure to hit that subscribe button and ring the notification bell. Next week, we're diving into another historical mystery that connects ancient accounts with modern scientific discoveries. The story of advanced civilizations that may have existed before the last ice age and the evidence they might have left behind. This is Javis Heist, where we explore the mysteries that mainstream history prefers to ignore. Until next time, keep questioning, keep investigating, and keep your eyes on the skies and the ground beneath your feet. Stay curious, stay prepared, and remember the truth is often stranger than fiction.